Okay, this is part 2 of my review for test 4. And in the first part, I pretty much stuck with problems from chapter 10. And now we'll go on to problems from chapter 11. So here we're solving quadratic equations. And remember, there's essentially 4 different methods for solving quadratic equations. Here they tell us pretty specifically what method we should use here, right? So in number 13, we're supposed to use the square root method. So I hope you remember what that is. It obviously involves taking the square root. And in part A, we have x squared plus 81 equals 0. Now, before we can take the square root, we have to isolate, right, the x squared. So first thing I would do is subtract 81 from both sides. So you get x squared equals negative 81. Now we can take the square root of both sides. Yep, don't forget the plus or minus, right? Anytime you take the square root, you get a plus or minus. So square root of x squared, well, is absolute value of x, right? But we already took care of that with the plus or minus. Right. And square root of negative 81 is just 9i, as we saw at the very end of the last video, right? If you don't remember, then it's the square root of 81 times the square root of negative 1. The square root of 81 is the 9, and the square root of negative 1 is I. So this has two solutions, right? It has x equals 9i and x equals negative 9i. But they are imaginary numbers, right? So the solutions are not real numbers here. They're imaginary numbers. All right, let's go on to part B. It's r minus 3 squared equals 64. So here, we don't have to add or subtract anything. The square is already isolated. So all we need to do now is just get rid of that square. And we do the inverse. We take the square root of both sides. Don't forget the plus or minus. So r minus 3 is plus or minus the square root of 64. Right? It's not the square root of negative 64. So there's no I here. Square root of 64 is just 8. So when we add the 3 to both sides, remember, you want to do it this way. Plus 3 on the left, plus 3 on the right. So r is 3 plus or minus 8. And we can't leave it like that because there's two actual numbers here, right? So 3 plus 8 is just 11. And 3 minus 8 is negative 5. Right. And you should check. Plug them back into the original equation, and you'll see they both work. Okay. So we have two answers here, 11 and negative 5. Any order is fine. If you remember on Connect Math, they sometimes wanted it as a set, the set of numbers negative 5 and 11. I mean, I would accept that too, but I'm really just looking for the two numbers, the negative 5 and the 11. All right, and finally part C. Okay, so here's 13C. 3y minus 1 squared minus 6 equals 0. So here we cannot take the square root of both sides yet. We have to add the 6 to both sides first. Right. Now we can take the square root of both sides. Don't forget the plus or minus. So the left side is just 3y minus 1. And the right side is just plus or minus square root of 6. Right, square root of 6 is, we can't simplify that any further. So now it's just solving for y, right? And I would add the 1 to both sides first. So 3y is 1 plus or minus the square root of 6. And then divide by the 3. So y is going to be 1 plus or minus the square root of 6 all over 3. Right. And just realize there's two answers here, right? There's 1 plus the square root of 6 over 3. and 1 minus the square root of 6 over 3. So it might be helpful to write them separately. Again, with the plus or minus here is fine too. So you can leave it that way, or you can write them separately. And just, right, there's no i's here, right? So these are real numbers, and in fact, you can use your calculator to approximate. And this is what my calculator gives me. So 1 plus square root of 6 over 3 is about 1.1498, and 1 minus the square root of 6 over 3 is about negative 0.4832. But we're not looking for those, right? We want the exact answers here, right? So these are exact, these are approximate. Yeah. All right, part D for number 13, x squared minus 32 equals 0. Now 32 is not a perfect square, so this is not amenable to factoring. So as before, let's just add the 32 to both sides, and then take the square root. Don't forget the plus or minus. So x is just going to be plus or minus the square root of 32. But we should simplify that, right? So 32 is 16 times 2, and 16, the square root of 16 rather, is 4. So x is just going to be plus or minus 4 square root of 2. And you can write them separately, 4 square root of 2 and negative 4 square root of 2. But in this case, you can also write them together. Part E, we have t minus 5, the quantity squared, is equal to negative 100. So I think because the squared is isolated on the left, we can just take the square root of both sides. Don't forget the plus or minus. So t minus 5 is equal to plus or minus the square root of negative 100, which is not 10, right? It's 10i because of it's a negative, right? And then just add 5 to both sides. So t is going to be 5 plus or minus 10i. Right? Splitting them up, you have t is 5 plus 10i, or 5 minus 10i. So you could write them separately. Just remember, it's not 15. It's not 15i, right? You can do 5i plus 10i. That would be 15i. But 5 plus 10i is just 5 plus 10i. You cannot simplify that any further. Right. I mean, you could factor out a 5, but there's no point in doing that here. All right. And then finally for part F, again, we'll just do this quickly. 8x plus 3 squared minus 40 equals 0. So first thing is to add the 40 to both sides. Right. And then take the square root plus or minus the square root. Right. So 8x plus 3 is equal to plus or minus the square root of 40. Before we go any further, I think we can simplify square root of 40, right? It's just the square root of 4 times the square root of 10. No negatives, right? So it's not imaginary. There's no i's. But the square root of 4 is 2, right? So 8x plus 3 equals plus or minus 2 square root of 10. Right. So take away the 3. And remember, I warned you, you should put the negative 3 in front. Plus or minus 2 square root of 10, and then just divide by 8. So x equals, let's see, negative 3 plus or minus 2 square root of 10 all over 8. And I don't think we can simplify that any further. Right? We can split it up as two separate, one with the plus, one with the minus. But yeah, that's it for part F. All right, number 14 is to solve by completing the square. Everyone's favorite, I'm sure. I'm kind of joking there, right? So this is that really lengthy process here, right? And I'm going to go through it step by step one last time. And then I think for all the others, I'm going to go through them rather quickly. Okay, so step 1, if you remember, is to write it in standard form. And in this case it is. Right. Step 2 is to subtract the c from both sides. Oh, actually, I'm sorry. Step 2 is to divide by a on both sides. Here a is 1, so it doesn't really matter. If you want to divide by 1, that doesn't change anything. Right? So step 3, now we subtract the constant from both sides. In this case, the constant is 10. So in step 3, we're subtracting 10 from both sides. So we end up with x squared plus 6x equals negative 10. Step 4, take the number in front of the x, take the coefficient of x, right? Cut it in half or divide it by 2, and then square it. So in this case, we have 6 divided by 2 squared. Well, 6 divided by 2 is 3, and 3 squared is 9. So what do we do with that 9? We're going to add that number, 9, to both sides. Oh, so I think that's step 5. Add 9 to both sides. So, yep, step 5 is to add 9 to the left side and add 9 to the right side. So what we have on the left is x squared plus 6x plus 9. And on the right side, negative 10 plus 9 is negative 1. Okay, so now we complete the square, right? We essentially factor the left side as a perfect square. Right. So in this case, that's just x plus 3 squared. Right. So hopefully you remember your factoring, right? And this is just a perfect square here, right? Step 7, well, now just take the square root of both sides. So apply the square root property here. So square root of both sides, right? Which is what we just did, right? So take the square root of the left side plus or minus the square root of the right side. So the square root on the left cancels the square, so we just get x plus 3. And on the right side, the square root of negative 1 is just the letter I. So now just take away the 3 from both sides, and we get x equals negative 3 plus or minus I. Oops, there's the I. And that'll do it. Right? So those are our solutions. Remember, there's 2 of them. X equals 3 plus I, and x equals 3 minus I. So either way, if you want to write them separately, that's fine. If you want to write them both at once, that's okay too, at least in this problem here. In some problems, you know, you have to split them up. Right? And we saw one like that already, if you remember. Well, I don't remember it either, but it was something like this, right? If you have 3 plus or minus 7 over 2. Don't leave it like that, right? 3 plus 7 is 10, and 10 divided by 2 is 5. Right? And 3 minus 7 is negative 4, and negative 4 divided by 2 is negative 2. So if you ever see something like this, I'm not looking for that. I'm looking for the 5 and the negative 2. But because you have the square root that's not a perfect square, or in this case imaginary, you're welcome to leave it like this with the plus or minus. All right, now let's go on to part B. Okay, w squared minus 8w equals 20. All right, so we're solving for w instead of x. Right? Don't let that bother you. Right? And a is already 1, so we don't have to divide by anything. And the constant's already on the right. So we're already at step 3 here. wait a minute, step 3 is to do the constant, right? So yeah, we already did that. Step 4 is to find the number that we're adding to both sides. So take the negative 8, right, the number in front of the w in this case, there's no x. So divide it by 2 and then square it. When you divide it by 2, you get negative 4, and then when you square it, you get positive 16. So in step 5, we're going to add 16 to both sides. Right? And 20 plus 16 is just 36. Right. Step 6, now we factor the left side as w minus 4, quantity squared. And then step 7, take the square root of both sides. And that cancels the square. Right. So on the left we have w minus 4. On the right we have plus or minus the square root of 36. Well, that's just 6. Right? So now just add the 4 to both sides. And w is going to be 4 plus or minus 6. And this is where I warned you, right? There's no I, there's no, square root of 7. So we can't leave it like that. You have to split them up and write them separately, right? Because 4 plus 6 is 10, and 4 minus 6 is negative 2. So the solutions are negative 2 and 10. So w is equal to negative 2 and 10. All right. And yes, you could have gotten this by factoring, but the directions specifically said complete the square. So you have to do it this way. Sorry, but you have to get used to this too. Right? Okay, so let's do a few more. X squared minus 41 equals 4x. Okay, problem is this is not in standard form, so we really need to subtract the 4x from both sides here. So first thing is x squared minus 4x minus 41 equals 0. Right. Luckily a is 1, so we don't have to divide by anything, but we do want to add the 41 to both sides. So now we have x squared minus 4x equals 41. So what are we adding to both sides? The negative 4, cut it in half and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So let's add 4 to the left side. Let's add 4 to the right side. And by doing that, the left side is factorable as a perfect square. Right? So the left side factors as x minus 2 times x minus 2, or x minus 2 squared. And notice on the right side I did 41 plus 4 is 45. I think you can all handle that. Now get rid of the square, so let's take the square root of both sides. And when you do that, don't forget the plus or minus. So square root of the right side, square root of the left side. So that gets rid of the square. We have x minus 2 is equal to plus or minus the square root of 45. I think we can simplify that, right? 45 is 9 times 5. And the square root of 9 is 3. Right? So this is really just going to be 3 square root of 5. So add the 2 to both sides, and it looks like we get 2 plus or minus 3 square root of 5. And here, because we can't simplify the square root of 5 any further, we can leave it like that, or you can write them separately. I am not going to ask you to approximate. Save that for your science classes, your chemistry or physics. They will ask you to approximate those. So just plug them in your calculator to do that. All right, so that's part C. So part D, right, number 14, part D, we're still supposed to complete the square. And we want to solve 2x squared minus x minus 9 equals 0. This is a hard one, right? This is one that, if it comes up on a test, it's probably going to be one of the more challenging ones. But let's do it, right? Remember, step 1 is to put it in standard form. luckily, they gave it to us in standard form, so nothing to do there. Step 2 is to divide both sides by a. Now here, a is 2. So here, we have to divide everything by 2. Okay, so you're going to get x squared minus 1/2 x minus 9 over 2 equals 0 divided by 2 is still 0. Right? But you can see what's going to make this pretty awful is the fact that these are now fractions. But of course, you sometimes have to deal with fractions, for better or worse, right? Right. Step 3 is to subtract the constant from both sides. Here the constant is negative 9 over 2. So to do the opposite, we're going to add 9 over 2 to both sides, right? So we're going to get x squared minus 1/2 x plus 0 equals 9 over 2. Okay, so far. All right, so number 4 is the separate step. You take the coefficient of x, the negative 1/2, right? You divide it by 2. Well, that's the same as multiplying by 1/2. So you get negative 1/4. And then don't forget to square the whole thing. When you square negative 1/4, you get 1 over 16. So we're going to add 1 over 16 to both sides. That's step 5. So 1 over 16 on the left plus 1 over 16 on the right side. Right, on the left side, we're going to have x squared minus 1/2 x plus 1 over 16. And on the right side, common denominator, right? I think we want to multiply the first fraction by 8 over 8. So we're going to get 72 over 16 plus 1 over 16, so 73 over 16. Yep, you got to know how to add fractions, right? So that was way back in chapter 7. All right, now what? Now we should be able to factor the left side, right? That's step 6. And you might be thinking, wait a minute, factoring with fractions? I've never had to do that. And you probably haven't. I don't think it came up all that often. So back in chapter 6 when we were factoring, I don't think we ever saw fractions like this. I mean, maybe, but not very often. Okay, so here the trick is, remember that this is a perfect square trinomial. Right? So just to remind you, what do we mean by a perfect square trinomial? We mean this. We mean a squared, in this case, minus 2ab plus b squared. And that factors as a minus b squared. Okay, so now it's just mixing and matching, right? This is a squared minus 2ab plus b squared. So we want to factor that as a minus b squared. Again, this will come up later, right? We'll worry about the 73 over 16 later. Right now we're still factoring. So it should be clear that a is just x, right? It should be clear that b squared, right, is just 1 over 16. Right? Yeah, but a squared is x squared, so a is x. And b squared is 1 over 16, so b is just the square root of 1 over 16, which is 1 over 4. Right? And so negative 2ab is negative 2 times x times 1 over 4, which is just negative 1/2 x, which is what we have. So this works out perfectly here, right? So that means we should be able to factor this as a minus b squared, where a is just x and b is 1/4. Okay. So, yep, that's how to factor when you have fractions like this. The key is that it is a perfect square. So you have to remember how to factor perfect square trinomials. Okay, step 7. Now we have a perfect square on the left. And so to get rid of this square, we do the inverse, or the opposite. We take the square root plus or minus the square root of the right side, right? So x minus 1/4 is going to be plus or minus, well, square root of 73 over square root of 16. Now, 73, I think, is a prime number. Even if it's not prime, I don't think it's divisible by any perfect square. So it's not divisible by 4 or 9 or 16 or 25 or so on, right? So I think it's just the denominator. The square root of 16 is just 4. So the right side is plus or minus the square root of 73 over 4. Now, all we're going to do is just add the 1/4 to both sides. Right, so we're going to add 1/4 to the left side, add 1/4 to the right side. This is 0, so x equals 1 over 4 plus or minus the square root of 73 over 4. And you could leave it like that, or you could say we have a common denominator of 4. So I'm just going to add and subtract the numerators. This is 1 plus or minus the square root of 73 all over 4. So I'm happy with either at this point. So yeah, that was a tricky one because when a is not 1 here, because of the 2 in front, yeah, that made this kind of a pain with all these fractions here. Okay, so as I said, part D was a tricky one. Part E is not. Part E should be fairly standard here. The only tricky thing, I think, is that it's y instead of x, but again, don't let that bother you. Here you're solving for y, right? Y equals what? Okay, but we're still completing the square, and a is 1, so we don't have to divide by anything other than 1. And the constant's already on the right side, right? So we essentially, this was plus 58 equals 0, and we subtracted the 58 from both sides. Or rather, they did that for you, right? So step 4, all we're going to do now is take the negative 14, divide it by 2, and square it. So negative 7 squared is 49. I'm going to add 49 to both sides. Okay, so the left side, y squared minus 14y plus 49. And on the right side, negative 58 plus 49, I think is just negative 9. Right, so now we just factor the left side. It's going to be y minus 7 squared equals negative 9. Again, where did I get the negative 7? Well, you can just take the negative 14 and divide by 2, right? Or you could take 49 and take the square root. Just remember that the sign stays the same here. It's a negative. Okay, so y minus 7 squared equals negative 9. We're almost done. Just take the square root of both sides. So y minus 7 equals plus or minus square root of negative 9 is 3 times I. So just add the 7 to both sides, and you get y equals 7 plus or minus 3 times I. All right. Yeah, one more, part F. Okay, so we're solving x squared minus 5x plus 7 equals 0, also by completing the square. All right, a is 1, so we don't have to divide by anything. And it's already in standard form, right? So I think now we just subtract the 7 from both sides. So we get x squared minus 5x equals negative 7. Okay, now we take the number in front of the x, right? That's the negative 5. Divide it by 2, and then square it. So we're going to get positive 25 over 4. Yep, we get a fraction. We have to add 25 over 4 to both sides. Right? Yeah, so even though we didn't divide by anything in the second step, because this is an odd number, when you take an odd number and divide it by 2, you don't get a whole number anymore. So that's unfortunate. So what do we do on the right here? A negative 7 over 1 plus 25 over 4. So we'll have to multiply by 4. Negative 28 over 4 plus 25 over 4 is, I guess, negative 3 over 4. So the left side is x squared minus 5x plus 25 over 4. And the right side is negative 3/4. Okay, again, just getting a common denominator here. All right, now what do we do? Well, now we have to factor the left side. And again, there's a fraction here, but remember, this is a perfect square. So, right, a is x, b is 5 over 2. So just take this negative 5 and cut it in half. This is minus 5 over 2, right? Minus 5 over 2 squared. All right. Now take the square root, plus or minus. And on the left, you get x minus 5 over 2. On the right, you get plus or minus, well, let's see. This is going to be the square root of negative 3 over the square root of 4. The square root of 4 is just 2. But the square root of negative 3 is I times the square root of 3. Right? Because it's negative, it's going to be imaginary. Okay. Oh, I'm running out of space here. All right, so let's just do this up here. We have x minus 5 over 2 equals, plus or minus I times the square root of 3 over 2. So the only thing left to do now is add the 5 over 2 to both sides. All right, so on the left, these just add up to 0, leaving you with x equals 5 over 2 plus or minus I root 3 over 2. And they have a common denominator, right? The 2 is common, so we can combine everything. This is 5 plus or minus I squared of 3 all over 2. And I think I already mentioned I'm not picky. You could leave it either way at this point. But that's it, right? So that's completing the square. Once you get used to it, it's just not that bad, but it takes a while to get used to it. So hopefully, way back in 11.1, you did enough of these where this is now second nature. Okay, number 15. Moving right along. So here we're solving quadratic equations, but now we're going to use the quadratic formula. And as long as you know what the quadratic formula is, if you have it memorized, this is not as bad as completing the square. So what is the quadratic formula? Well, this is not the quadratic formula. This is a quadratic equation in standard form. This is what we're trying to solve, right? We're trying to solve this equation. The quadratic formula, then, are the solutions. X equals, opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula here, right? So you need to know it in order to use the quadratic formula to solve these equations. So, for example, in part A, we want to solve x squared plus 4x minus 9 equals 0. So this is in standard form, and in order to use the formula, you need to know what a, b, and c are, right? So a is just 1, b is 4, and c is negative 9. So we're going to take these three numbers and just plug them into the formula. So I think we can all do that. Again, I like writing down the formula every time. Help me to remember it. Now we can plug in the numbers, right? B is 4, so negative b is negative 4, plus or minus the square root of, well, b squared, so 4 squared, minus 4. Okay, don't get confused. This is always a 4 here, right? Times a, which is 1, times c, which is negative 9. And then all divided by 2 times a, or 2 times 1. Okay, that's it. Those are the answers. Obviously, we can't leave it like this. This is a mess. So let's clean it up. Let's simplify it, right? So we have the negative 4 plus or minus, right? The hard part here is what is this under the square root? Right, so the square root of what? Well, 4 squared is 16. And then negative 4 times negative 9 is positive 36. Right. And 2 times 1 is 2, so nothing to do there. 16 plus 36 is 52. Right. Be careful. I hope you're not doing 4 plus 6 is 10. Right. You cannot split up the square root like that, not when you're adding or subtracting. So you do 16 plus 36 is 52. And now we just have to simplify the square root of 52, which I'm running out of space here. Oops, sorry, negative 4 plus or minus. So 52 is what? Let's see, well, it's 26 times 2, but 26 is 13 times 2. So 13 times 4. Right. And the square root of 4 is just 2. So negative 4 plus or minus 2, square root of 13 all over 2. And we can go one step further because we can split this up as negative 4 over 2 plus or minus 2 square root of 13 over 2. So negative 4 divided by 2 is negative 2. And then 2 divided by 2 is 1, so plus or minus the square root of 13. So those are our solutions. X equals negative 2 plus or minus the square root of 13. Okay, so that's the idea of using the quadratic formula to solve your quadratic equation. And yes, we could have used completing the square here, and I would almost think it's easier to complete the square. That's just me. But again, I wanted to do this step by step using the quadratic formula. That's what the directions said to do, and that's the way I did it here. All right, so moving on to part B. Okay, so here we're solving the equation 10 times the quantity x minus 1 equals x squared, again using the quadratic formula. Okay, so remember, the first thing you need to know is what is A, what is B, what is C. And in this form, that's not pretty easy to determine. Right? It's not in standard form. Right? So the first thing I think we should do is write it in standard form. Ax squared plus bx plus c equals 0. Okay, so how do we do that? Well, clearly the x squared is on the wrong side. So maybe just switch sides. Also, we can distribute the 10. So x squared equals 10x minus 10. But it has to equal 0, right? So we'll subtract the 10x and we'll add the 10 to both sides. Right. So now it'll equal 0. The left side is x. I got to write this a little bit bigger. X squared minus 10x plus 10 equals 0. So now we can see in this form A is 1, B is negative 10, C is positive 10. So plug these into the quadratic formula, which I will write down again. Negative B plus or minus the square root of B squared minus 4AC all over 2A. And now just plug in the numbers, right? B is negative 10 plus or minus the square root of negative 10 squared minus 4 times A, which is 1, and C is 10, all divided by 2 times 1. Okay, so those are the answers. Now let's just simplify all this. So negative 10 is positive 10, plus or minus the square root of negative 10 times negative 10 is 100, and then minus 40 all over 2. So this is 10 plus or minus the square root of 60 all over 2. And 60 is not a perfect square, but we can essentially decompose it, right, it's 4 times 15. So we get 10 plus or minus the square root of 4 times the square root of 15 all over 2. But the square root of 4 is 2. And now we just split this up, right? 10 over 2 plus or minus 2 square root of 15 over 2. 10 divided by 2 is 5. 2 divided by 2 is 1 times the square root of 15. So there you go. Those are your solutions to this equation. The solutions are x equals, oh, I forgot. Yeah, 5 plus or minus the square root of 15. And I don't think there's any way to simplify that any further. So, right. You can leave it with the plus or minus. I mean, you could split them up as one with the plus and the other with a negative. Right? They are two separate answers, two distinct answers. But yeah, in this case, you can combine them both into one statement, two answers. All right. Yeah. One thing you have to be careful of, and I see, unfortunately, I see too many people do this, is that they like to cancel the 2's here. If you do that, you're going to get it wrong, right? You're going to get 10 plus or minus the square root of 15. But it's not 10, is it? It's 5, right? You have to divide the 10 by 2 as well, which is why I prefer to split them up like this before you start canceling, right? You can cancel the 2's here because it's just one thing, right? You're just multiplying here. And you can cancel the 2's here to make it 5, but you cannot cancel them here, right? It just doesn't work, right? You get the wrong answer. So yeah, don't make that mistake. All right, moving on to part C here. Okay, so we want to solve the equation 12x squared minus 5x minus 3 equals 0. And lucky for us, it's already in standard form, right? Unlike part B, we first had to manipulate it to get it to look like this. But here it already does. So we can identify A is 12, B is negative 5, and C is negative 3. So we plug those into the quadratic formula. Here it is again, plus or minus, I'm sorry, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now plugging in the numbers, right? B is negative 5, so we have negative 5 plus or minus the square root of negative 5 squared minus 4 times a, which is 12, times c, which is negative 3. And then the whole thing divided by 2 times a, so 2 times 12. All right, so let's simplify this. Negative 5 is positive 5. Then plus or minus the square root of negative 5 squared is 25. And then minus a negative, so it's going to be plus 4 times 12 times 3. So I think that's 144. Right, 4 times 3 is 12. 12 times 12 is 144. Over 2 times 12, which is 24. Okay, so 25 plus 144, I think is 169. We should double check that. I think that's right. And the square root of 169, that turns out to be a perfect square. That's just exactly 13. Okay. So we have 5 plus or minus 13 all over 24. Now, here we cannot leave it like that, right? Because it's not the square root of 13, right? It's just 13. These are nice whole numbers here. Well, when you divide by 24, they will be rational numbers. But yeah, let's just split them up into the two separate fractions here, right? 5 plus 13 over 24 is what? 5 plus 13 is 18. 18 divided by 24, let's see. 18 is 6 times 3. 24 is 8 times 3. Oh, I could have gone one step further. I could divide by 6, right? So 24 is 6 times 4. There we go. The 6's cancel, leaving you with 3 over 4. Is that right? Yeah. So 3 over 4. Right. But that's only one answer. The other answer is 5 minus 13 over 24. And 5 minus 13 is negative 8. And negative 8 over 24 reduces to negative 1 over 3. So those are our two solutions here, right? X is either going to be negative 1/3 or 3/4. Okay. So yeah, when A is not 1, I think as it was in the last two problems, you're going to more likely you're going to get fractions or worse. So that's part C. All right, I'm going to skip part D because it's pretty similar to part C. And in fact, A is 1, so I think it should even be easier, in my opinion. You might just get bigger numbers, but it's using the same formula, right? I'm going to do part E because this is not as easy. For one thing, it's not in standard form, right? We have to distribute the 3x. So this is 3x squared minus 3x equals 10. And we have to subtract the 10 from both sides. So we get 3x squared minus 3x minus 10 equals 0. So now we can identify A is 3, B is negative 3, and C is negative 10. So plug these into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in the numbers, we have again a negative of a negative, so that'll become a positive 3 on the next step. Plus or minus the square root of negative 3 squared minus 4 times 3 times negative 10 all over 2 times 3. So positive 3 plus or minus the square root of what? The square root of 9 minus 12 times negative 10. So that's going to be a positive 120. Yep, 12 times 10 is 120, right? Divided by 2 times 3, which is 6. So 3 plus or minus the square root of 129 all over 6. And I think that's it, right? Now, the only question is, can we simplify 129? Well, let's see. If we divide by 3, I think we get 43. But 43 is a prime number. So yes, we could split up the square root of 129 as the square root of 3 times the square root of 43, but neither of these are perfect squares, which means there was no point in doing that. We'll just leave it like this, right? Again, it's a good idea to check, but in this case, it just wasn't, it turned out not to be necessary to do that. Right? And then part F, 15F, I was almost going to skip this too, because if you can do C, I think you can handle this. It's already in standard form, right? A is 5, B is 9, C is 12. Plug them into the formula. At some point, you're gonna get so used to this that it's almost too easy. Right, so B is 9, right? So negative 9 plus or minus the square root of 9 squared minus 4 times 5 times 12, right? All under the square root, divided by 2 times 5. So negative 9 plus or minus the square root of 81 minus, let's see, 20 times 12, I believe is 240, all over 10. And 81 minus 240, I'm going to bring up a calculator because I can't do that in my head here. You get negative 159. So because it's negative, we're definitely going to get an imaginary, or a set of imaginary numbers here, I times the square root of 159 over 10. Now, again, the only issue is, can we simplify the square root of 159? What's 159 divisible by? Well, it's divisible by 3. So it's 3 times 53. And 53 is divisible not by 2, not by 3, not by 5, not by 7. No, it's prime. So again, 3 times 53, oops, sorry. But these are not perfect squares. So in fact, we just leave it like this. Okay, so negative 9 plus or minus I square root of 159 all over 10. Okay, so that's the quadratic formula, right? Very useful. It allows you to solve any quadratic equation as long as it's in standard form, right? So you first have to write it in the form ax squared plus bx plus c equals 0, because you have to identify the a, b, and c as the coefficients. Once you know a, b, and c, you plug them into the formula and you get your answers. It's just a matter of being careful of all the arithmetic, in particular what's under the square root. Be careful of that. And all right, so moving on to number 16. Right, in number 16, we're still solving quadratic equations. But here, they do not tell us what method to use. We can do it any way we want. Right? We can do this any way we want. So, you know, pick your favorite method, I guess. You can always use the quadratic formula. That always works. You can complete the square. That always works. It might not be the best way or the easiest way, but it always works. The square root method, of course, does not always work, and factoring does not always work. Right. So when I look at this, 1/2 r squared equals r plus 45 over 8, I think this is a complete mess, right? We have fractions, right? It's not in standard form. So we can put this in standard form pretty easily, right? We'll just take the 1/2 r squared, we'll subtract the r from both sides, and we'll subtract the 45 over 8 from both sides, and that equals 0 now. Okay. So in this form, a is 1/2, right? B is negative 1, and c is negative 45 over 8. So you can plug those into the quadratic formula, but it's a mess. You have fractions here. And I think in number 15, I don't think we saw any fractions. So here's what I would do. Before you plug them into the formula, we can just multiply by the least common denominator. What's the least common denominator? It's the 8, right? It's not the 2. It's the 8. We're going to multiply both sides by 8. Right? And if we do that, what do we get? We get 8 over 2 times r squared minus 8 times r minus 8 times, well, 45 divided by 8. And 0 times 8 is still 0. So we get 4r squared minus 8r, and then because the 8's cancel, minus 45 equals 0. So, yeah, by multiplying by the LCD here being 8, right, we got rid of the fractions, right? Nobody likes fractions, and whenever you're solving an equation, it's best to multiply by the LCD to get rid of the fractions, to get rid of the denominators, right? Now the denominators are just 1. Right. So in this form now, A is 4, B is negative 8, and C is negative 45. So how about quadratic formula again, right? Now we can easily plug this into the quadratic formula, right? R equals negative B plus or minus the square root of b squared minus 4ac all over 2a. So here b is negative 8, so it's going to be a positive 8 plus or minus the square root of, let's see, negative 8 squared minus 4 times a is 4 times c, which is negative 45, all over 2 times 4. So that's going to give us positive 8 plus or minus the square root of 64. And now it's minus a negative, right? So 16 times 45, it's going to be a big number, 720. Right, so plus 720, all divided by 2 times 4, which is 8. Okay, so 720 plus 64 is 784. And yeah, let me write that down. So, sorry, 8 plus or minus the square root of 784 all over 8. Okay, so that's it. Can we go any further? So 784 is 28 times 28, right? It's a perfect square. So it's 28 squared. So this is just 8 plus or minus 28 all over 8. Okay, so now we got to keep going, right? Be careful. It's not 8 divided by 8 is 1 plus or minus 28. I warned you about that already. Let's just do both the plus and the minus separately. So the plus is 8 plus 28 over 8. 8 plus 28 is 36. 36 divided by 8. Well, if we divide by 4, that reduces to 9 over 2. So that's one answer. The other is 8 minus 28 over 8. 8 minus 28 is negative 20 divided by 8. And again, if we divide by 4, we get negative 5 over 2. So R, we have two solutions here, 9 over 2 and negative 5 over 2. I realize I put the bigger one first, but order doesn't matter as long as you have the two solutions. Right. Here's the way that Connect Math would prefer it, but I am not picky about that. Right. So either way, 9 over 2 and negative 5 over 2. I would even take decimals here, right? You can do 4.5 and negative 2.5. You know, if you put that down, yeah, I'll just assume you just use your calculator. Okay, so that's it for the quadratic formula. That's 16a. 16b, you know what? I think you can handle that because it's already in standard form, right? So a is 1, b is negative 12, and c is 24. You can just plug those into the quadratic formula. But I will do part C. Okay, so 16c, we want to solve 3x plus 8 quantity squared plus 9 equals 0. And remember, we could do this any way we want, right? We weren't given specific directions about what method to use here. Okay, so I'm going to do this by actually, it's not even completing the square, is it? It's just the square root method. It was the very first one we did here. Right? All we have to do is subtract the 9 from both sides. Well, that's not all, but that's the first step, right? And then just take the square root of both sides. That gets rid of the square on the left. And then we get plus or minus the square root of negative 9. So 3x plus 8 is equal to plus or minus 3 times I. Subtract the 8 from both sides, and then divide by 3. So x equals negative 8 plus or minus 3i all over 3. Right. And right, you could split this up, negative 8 over 3 plus or minus I. 1 times I. So either way is fine. So square root method, I think, is the most direct, the quickest way to do this. On the other hand, if you want to use the quadratic formula, you have to multiply this out first, right? So 3x plus 8 times 3x plus 8 plus 9 equals 0. So it already equals 0, but in this form, we have no idea what the a, b, and c are. So once we expand this out, I'll do that over here. What do we get? 9x squared plus 24 times 2, 48x plus 64 plus 9 equals 0. And 64 plus 9 is, 64 plus 9, 73 equals 0. So A is 9, B is 48, and C is 73. So you can plug these numbers into the quadratic formula. If you do that, you should get the same thing we did here. It's just a lot more work, right? So in this case, because essentially we had this perfect square here, that led me to do the square root method. But if you prefer to multiply it out like this, put it in standard form. This is the, this is the standard form. Now you know what A, B, and C are. Now you can plug them into the quadratic formula. Still a lot of work to do that. And keep a calculator handy so you don't mess up the arithmetic. But in the end, you should get the same answer as we did here. All right, so I'm not going to do it, I would encourage you to do it by using the quadratic formula as well. But here we could have done it either way. Right, and the one thing you don't want to do is complete the square on this. If you do that, you'll eventually just end up with this, which you can get by the square root method originally. So I hope that helps. Right, and so that brings us to chapter 13. So what we've done so far is chapter 11, I believe. And now I think in section 13.1, there's just two more topics here, the distance formula and the midpoint formula. So in number 17, we're going to use, well, it's asking for, right, distance. So we need the distance formula between 2 points. And that you should know. We have 2 points, let's say x1, y1, and another point, x2, y2. The distance between them, right, I'll just call it d for distance. It's going to be the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Okay. So we're just going to plug in all these numbers into the distance formula, right? So for part A, we have 8, negative 2, and 6, negative 6, negative 6. So x1, y1, x2, y2, right? So x1 is 8, y1 is negative 2, x2 is 6, and y2 is negative 6. So just plug these numbers into the formula here, right? So our distance d is going to be the square root of 6 minus 8 squared plus negative 6 minus negative 2 squared, all under the square root, right? So 6 minus 8 is negative 2. Don't forget to square it. And negative 6 minus negative 2 is negative 4. Don't forget to square that. I hope you saw that, right? Negative 6 plus 2 is negative 4, right? Minus a negative is positive. So negative 6 plus 2, yeah, negative 4. All right. Now, what's negative 2 squared? It's positive 4. What's negative 4 squared? It's positive 16. And what's 4 plus 16? It's 20, but don't forget the square root, right? So square root of 20, and we can simplify that as square root of 4 times square root of 5, and square root of 4 is 2. So 2 square root of 5 is our answer, right? So that's the distance between the 2 points. 2 square root of 5, right? Oh, it did say to round to the nearest hundredth. For that, you need a calculator. So just take the square root of 20, and it's approximately 4.472. Oh, that's thousandth. Hundredth is just 2 decimal places. So 4.47. Okay. So yeah, they wanted that too. That's the approximate using your calculator, and then this is the exact answer, just simplified. Well, the square root of 20 is also exact, but in general, you want to simplify it as well. So. All right, so that's part A. Part B, I think you can handle. You're just doing bigger numbers. So I'm gonna jump to part C, which are smaller numbers, but they're also decimals. So again, this is where you might need a calculator here. Okay, so these are the 2 points, right? This is our x1, y1, x2, y2, and I'm going to write them down just so I know which is which. x1 is 7.3, y1 is 2.4, x2 is negative 1.9, and y2 is 10.8. So we're looking for the distance. Here's the distance formula again. X2 minus x1 squared plus y2 minus y1 squared, all under the square root. Right. I mean, we've been talking about square roots, so this is where this comes in handy. When you're finding the distance, it's probably going to be a square root, right? All right, so x2 is negative 1.9 minus x1 is 7.3 squared. And then y2 is 10.8 minus y1 is 2.4, again, squared. So what are we taking the square root of? Well, what are we squaring here? Negative 1.9 minus 7.3. I want to say negative 9.2 squared. And then 10.8 minus 2.4 is, I believe, 8.4. Don't forget to square that. Right, and now this is where we really need a calculator. Negative 9.2 squared looks like 84.46. No, sorry, 84.64. Got that backwards. And then 8.4 times 8.4, 8.4 squared, 70.56. Right. Now remember, you're not adding you're not splitting these up, you're adding them, right? So 70.56 plus 84.64. My calculator says 155.2. And that's it. I mean, right, because we have a decimal here, I'm not going to try to simplify this. I mean, we could, but I don't see the point. So this is the exact answer. And then for the approximate, I get 12.46. Okay, so yeah, it's right. It's not tricky. It just requires a calculator to do all this. But yeah, those are the answers. That's the exact answer. That's the approximate. You should know how to get both. Certainly, just using your calculator. And for a real challenge, we're going to do part D here. And what makes it challenging, of course, is the fact that they are just fractions. So some of you might be thinking, well, I'm just going to use my calculator, so I'm just going to convert these to decimals. Please don't. That's not going to cut it here. In particular, it's because 5 over 3, you really can't write that as a decimal, right? It's 1.6666666666666, and I'm going to run out of space here. So yeah, we can't do that, right? So we're going to have to leave these as fractions. But it's done the same way. This is x1, y1, x2, y2. And we'll just plug those numbers into the distance formula. Here it is again. Right. So make it a little bigger because they're fractions. So what do we get? We get x2, which is 16 over 3, minus x1, which is 5 over 3 squared. And then y2 is negative 7 over 8, minus y1 is 9 over 4. All right. Well, this worked out pretty nicely because here the 3's is our common denominator. So it's just 16 minus 5. 16 minus 5 is 11. Right? Now, 7 over 8 and 9 over 4, we don't have a common denominator there. Or they're both negative, but that's okay. So the least common denominator here is 8. I'm going to multiply top and bottom by 2 on the second fraction. So I get negative 7 over 8 minus 18 over 8, which is negative 25 over 8. And then we got to square that as well. All right, so yeah, again, don't make the mistake of splitting this up. It's not 11 over 3 plus 25 over 8, or even minus 25 over 8, right? Yep, you got to square everything. 11 squared is 121. 3 squared is 9. Now, the negative doesn't matter here, because when you square it, it becomes positive. So negative 25 times negative 25 is 625. And 8 times 8 is 64. Okay. Now we need a common denominator here. And I'll tell you right now, it's just 9 times 64. They have nothing in common, right? So 9 is 3 times 3. 64 is, well, 8 times 8. So I'm going to do this fairly quickly here, right? We're going to multiply the first fraction by 64 over 64. And the second fraction by 9 over 9. Okay. So what we're going to end up with is 121 times 64 plus 625 times 9, all over 64 times 9. And again, we're going to get some pretty big numbers here. Let's see, so 121 times 64 is 7,744. Oops, 7744 plus 625 times 9. It's 5625. All divided by 64 times 9, 576. Okay, so the numerator then is 7744 plus 5625. Use your calculator. It's 13,369. That got moved down a little bit here. Right, over 576, clearly. Okay. And it turns out that 576 is a perfect square. It's just 24, right? The square root of 576 is 24. Right. How did I know that? Well, if you remember, the 576 came from 64 times 9. So in my head, I just did the square root of 64 times the square root of 9. I did 8 times 3, which is 24. But of course, you didn't have to do that. You could just do the square root of 576 on your calculator, and it'll just spit out the 24. Now, the 13,369, we should try to simplify that, right? But I don't know if it's a prime number. It's not divisible by 3. Oops. Is it divisible by 7? Nope. So I don't think we can go any further with this. I'm going to leave it alone. If I'm wrong, then I'm wrong, but you know, it's not a big deal at this point. So that's the final answer for part D. The square root of 13,369 divided by 24. And the approximate answer, that you can get pretty easily. It's 115.62439 divided by 24. Wait a minute, I did something wrong here. Let me try it again. 13369, take the square root of that, and then divide by 24. So 4.82 is the approximate. Okay. All right. All right, last problem, number 18. Okay, so in number 17, we were using the distance formula. Here, we're going to be using the midpoint formula, which again, I'm assuming you know that by now. Midpoint, don't use M for midpoint, because if you remember a long time ago, we used M for slope. So don't get confused with slope here. Midpoint and slope have nothing to do with each other. Right? We're not asking for slope at all. Okay. So just ignore that. Instead, midpoint is, well, you just take the x's, add them up, and divide by 2. And then you do the same thing for the y coordinate. Add them up and divide by 2. Okay, so that's the midpoint formula. Let's just do part A. So here we have negative 15 to negative 2, sorry, and 3 negative 20. So x1 is negative 15, y1 is negative 2, x2 is 3, and y2 is negative 20. So plugging those numbers into the midpoint formula, we're going to get, let's see, negative 15 plus 3 divided by 2, comma, right? And then y1 is negative 2. So negative 2 plus negative 20 divided by 2. And surely we can simplify that. Negative 15 plus 3 is negative 12. And negative 2 plus negative 20 is negative 22. Now, dividing them by 2, we just get negative 6, negative 11. And that's the midpoint, right? So we talked about the significance, right? If you're at point A and way over here is point B, right, the midpoint is just halfway in between them. This would be the midpoint, right? So it's a point, right? A point requires two numbers, an x and a y, right? The x is negative 6, the y is negative 11. In distance, you're only finding one number, right? Distance is a single number. Midpoint is two numbers, and it's an x and a y. It's an ordered pair. Okay. All right. Part B, I think you can handle that, but I'm going to do it anyways. We have time. Okay, so these are the 2 points, 4, 1, and negative 7, 14, right? So that's our x1, y1, x2, y2, always x then y. And I wrote down the numbers already. So now we just plug them into the midpoint formula, x1 plus x2 over 2, and then the y1 plus y2 over 2. Right? You're not subtracting. It's not x1 minus x2, right? That's the distance formula, right? Here we want midpoint. All right, so x1 plus x2 is 4 plus negative 7 over 2. And then y1 plus y2 is 1 plus 14 over 2. So I think we get negative 3 over 2 and 15 over 2. And because the numerator is not an even number in both cases, we can leave it alone. That's the answer. If you like decimals, it's negative 1.5, 7.5. I'm not picky. Either way is fine. Well, in this case, it's fine because, you know, they're terminating decimals. They're not those repeating decimals, right? It's not 0.6666 or 0.33333, right? Or even worse. Part C is done the same way, right? This is my x1, y1, x2, y2, and the midpoint formula again, x1 plus x2 over 2, y1 plus y2 over 2. Just plug in the numbers. So 12.6 plus 0 over 2. And 33.1 plus negative 4.4 over 2. Right, so we're going to get 12.6 over 2. And I need a calculator, right? So 33.1 minus 4.4. I should be able to do this in my head, right? I think 28.7. Right. Now don't forget to divide by 2. You're going to get 6.3 and for x, and for y, 14.35. And what tells me that I can leave them as decimals here is, well, the original problem contained decimals. These are all decimals. So, of course, you don't have to convert them to fractions. You can leave it as a decimal in this case, in terms of decimals anyways. Yeah, don't leave it like this. We have decimals and fractions, right? Simplify the numbers as much as possible. So I think I did that here. All right, and then part D. All right, so 18D, x1 is 9 over 7, and y1 is 5 over 3, x2 is 15 over 7, y2 is 13 over 2. So again, it might be tempted to just convert these to decimals. Unfortunately, that's not going to work here because when you divide by 7, you get a repeating decimal that's not very pleasant. The 5 over 3 is just, 1.666666 again, but again, it's repeating. The 13 over 2, this here is the only terminating decimal. That would be 6.5. All right, so we're not going to convert to decimals. We're just going to apply the midpoint formula directly here. Okay, so there's the midpoint. So we're going to get 9 over 7 plus 15 over 7, all over 2, right? Don't forget to divide by 2. And then for the y's, we have 5 over 3 plus 13 over 2, again, all divided by 2. Yeah, kind of a mess, right? We can't leave it like that. So what do? Well, let's start with just adding these numbers here. Notice we have a common denominator of 7. So let's just add 9 plus 15. 9 plus 15 is 24. So 24 over 7, all over 2. Now, these numbers here, we do not have a common denominator. The common denominator here is 3 times 2, right? It's going to be 6. So this is going to be 10 over 6 plus 39 over 6, which gives you 49 over 6. Right? So the numerator here is 49 over 6, and we're still dividing by 2. Right. But dividing by 2 is the same as multiplying by 1/2. So 24 over 7 times 1/2 for x, and then 49 over 6 times 1/2 for y. So this is just 24 over 14 for x, and 49 over 12 for y. And that's it. Oh, we can reduce the 24 over 14, right? That's just 12 over 7. So 12 over 7 for x and 49 over 12 for y. I don't think we can go any further with that. Okay, so again, we started with fractions here, and so we ended with fractions, as usually that's the case. But yeah, you don't want to write these as decimals. So please don't. Leave them in improper fraction form. I mean, if you want to write them as mixed numerals, I guess that's okay. This will be 1 and 5/7, and then 4 and 1/12. So you're welcome to do that. I don't know why you'd want to, but you can do that, right? But don't write them as decimals. Right, because it's not pleasant. In fact, I will tell you right now, if you write 12 over 7 as a decimal, it's equal to what? It's equal to 1.714285714285. So this is a repeating decimal. It goes on and on. What's the repeating part, though? That's not really clear, but you can see that the 7 here repeats, and everything after that is the same. So 1.714285, and everything after that it repeats. So these 6 digits repeat. So if I were to write 12 over 7 as a decimal, it would be this, 1.714285, but with a bar over that, indicating that that part repeats. As I mentioned, it's not worth it, right? It's just not a good idea to do that. So anyway, I think that's it. Distance formula and midpoint formula. Again, make sure you know the formulas for distance and midpoint. Obviously, the other formula you need is the quadratic formula, so don't forget the quadratic formula for solving the quadratic equation in Chapter 11. But those are the only 3 formulas you need. And again, you can sit down and try to memorize them for a little bit, but by writing them down every time you do a problem, that will go a long way in helping you remember it. And I think I mentioned this for the quadratic formula. There's also Pop Goes the Weasel. You can look that up on your Google device or whatever, and you can find somebody singing it. And if that helps you, great. I'm not going to stop you. All right, so that's it for test 4. All I can say at this point is best of luck.